Station 51, engine 27, engine 32, truck 105.
You're listening to The Fire Break with Steve Wolf. Welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire, who just put out the first wildfire ever suppressed with a jet engine. Super proud of my team here. Well, fire is no longer considered just a chemical reaction now. It is being recognized as a form of weather, right? Just like we recognize that lightning is weather, rain is weather, fire is also weather. And so it's falling squarely in the range of meteorological phenomena. And so we have with us today, live from Athens, Greece, Theodore Giannaros, who is a fire weather expert in Greece. Welcome to The Fire Break. How are you today?
Thank you, Steve. I'm fine, and thank you for hosting me. I look forward to our discussion.
Me too. So tell me, what's the research that you're doing? You're, I understand, with an aged and reputable research institute.
Well, as you already mentioned, I am a fire meteorologist or a fire weather meteorologist, and my research focuses mainly on the interface between weather and wildfires. And this is because weather, and more broadly the atmosphere, affects all components that determine how a wildfire will ignite, how it will spread, how it will behave. So we do research on assessing how weather and climate influence the probability of having a wildfire ignition, but we also study how the fire itself, which is the most interesting aspect of our work, creates its own weather. It alters the atmospheric conditions, creates its own circulations, and on certain occasions it becomes an extreme event that is really hard to deal with.
Yes. So when did we start to recognize the phenomena of fire creating its own weather?
I think it has been always recognized. However, I would say that it's only in the past few years that we have been seeing an increase in the frequency of these coupled fire atmosphere systems, wildfires that couple with the atmosphere and present this extreme fire behavior, that it had drawn our attention. I mean, weather and the ability of the fire to couple with the atmosphere has been always recognized, but in recent years, we have been seeing this occurring more frequently, with more intensity, and this is what worrying us. And within this context, we attribute it also to climate change from the perspective that climate change has created now an environment that it is more conducive to having this fire atmosphere coupling.
I see. So because of the change in what's happening in climate,
Exactly.
it's more conducive to fire, and then the fire kind of perpetuates that.
Exactly. Within the context of climate change, we have higher temperatures, we have more drought, more intense drought, and all this create a fire environment that is conducive to the fire itself. However, something that it is, I would say, more recently emerging in the literature and in the research we are doing is the effect of climate change on the structure of the atmosphere itself. Because quite often when we talk about fire weather, and if we look in the past how we addressed fire weather and the effect of meteorological conditions on wildfire spread and behavior, one would see that we would focus only on the surface. However, when we talk about these coupled fire atmosphere systems, we're not talking only about the surface weather, about temperature, humidity, wind. We also need to know what's happening within the depth of the atmosphere. How stable is the atmosphere? How buoyant is the atmosphere? How it can favor the fire atmosphere coupling? Because there are atmospheric dynamics that can influence if the fire is going to couple with the atmosphere. And for example, you could have higher level intense winds going down to the surface, being drawn down to the surface. And this requires an understanding of the dynamics that happen within the atmosphere, and more specifically within the lower part of the atmosphere, which we call the planetary boundary layer.
I see. So is it turning out now, that Aristotle was right, that fire is now one of the four most predominant elements?
Yeah. Aristotle was right, and Aristotle was also the founder of meteorology. He wrote the first text, what is considered the first textbook about meteorology, trying to describe what he was seeing in the atmosphere. I would say that I like to say that meteorology, especially today, is what I could call a missing piece in understanding these extreme wildfires. And that said, I think it's important to also distinguish between two types of wildfires we are now experiencing, because we have, let's call them the normal wildfires, the typical wildfire events that we've had in the past. Those events show a quasi-state fire behavior. They spread and behave according to the laws we have already devised. However, when we talk about these coupled fire atmosphere systems, we have a dynamic behavior when you have multiple interactions between the fire and the atmosphere and feedback loops, which are non-linear and we currently lack a good understanding of.
I see. So these nonlinear phenomena, they still obviously conform to the laws of physics. They just don't conform to things that we've seen previously.
Exactly. And this is a dangerous spot to be, because right now, when we experience extreme wildfires, like for example the ones that are currently ongoing in Manitoba in Canada, when we talk about these events that couple with the fire with the atmosphere, we do have some knowledge of what's going on in there, but to be brutally honest, we really don't know. We don't have laws to describe the actual physics happening to get what we call a process-based understanding of what's happening in there. And since we don't have a process-based understanding of what's happening in there, we cannot subsequently develop models or parameterizations or very effective predictive tools. So this is the direction that the research community is trying to take right now. And I would say that we need to borrow from the experience of meteorology and climatology. The problem we are facing today with extreme wildfires reminds me of the problems we faced once we encountered tornadoes, once we encountered hurricanes. And the first thing we did in these occasions, was to observe the phenomena, to retrieve direct measurements from them, and then return back to the lab and try to understand, to decipher what's happening and describe it in mathematical terms and physical parameterizations.
So how do you go about doing that to understand the process in these types of fires? What type of instrumentation are you looking at? You could put weather balloons up and watch them swirl around in a tornado. In a fire, it's much more difficult, right? Because the fire is more destructive. It'll burn up all your instruments. So are we using more space observation, or
exactly?
How do we get that data?
Yeah, that's the really hard part when we talk about understanding extreme wildfire events, because due to the hazardous natures of these events, it's not easy to be close to them. They also pose a threat to people, to firefighters, so it's not as simple as it may sound to retrieve observations from them. So basically, the tools we have to observe these extreme wildfire events are what we call remote sensing tools that enable us to observe these events from a safety distance. And one of the most promising tools right now are weather radars, the radars that we typically use to monitor the evolution of weather systems, delineate areas of intense precipitation or other extreme or severe weather phenomena, and lidars, equipment that allow us to penetrate through the smoke plume and retrieve information about both its composition, what are the pyrometeors that exist in there, and about the field of wind, which is very important, because when the fire couples with the atmosphere, it creates its own wind circulation. You can have vortices, and all these phenomena that we discuss about have paramount importance for the safety of those who operate not only on the ground, but also for those operating from the air.
So, and what is the range of suites that you would, or the range of instrumentation suites that you would define as remote sensors?
The range?
Yeah, so you said it included LiDAR.
The I would say lidars, radars, satellite remote sensing, space observations can be also used, but they are kind of limited in a sense that the instrumentation that is available from satellite remote sensing, it's not always able to penetrate the fire plume and cannot give us information about the real dynamics. It can provide us indications about the presence of extreme fire behavior development and the fire atmosphere coupling. However, we cannot get detailed observations. The real observations we need can be obtained either from mobile weather radars, from mobile lidars, from radio sounds, weather balloons that we can shoot in the vicinity or very close to a smoke plume. This is the range of the observations we can get right now.
Okay.
And of course, drones. However, you would like really, really strong, I would say, army kind drones that are able to penetrate the plume.
Interesting. Would you consider also that what you originally characterized as a normal fire becomes an abnormal phenomena when the concentration and frequency increase beyond a normal amount? That if you might normally have 2 or 3 of these normal fires a week, but now all of a sudden you get 50 of these normal fires in one day, then that in itself is an abnormal phenomenon.
Yeah, this is what we have been experiencing in recent years. I mean, when people listen to us talking about climate change and extreme wildfire events, they often say that, okay, but we had some very disastrous and very catastrophic wildfires in the past. And this is absolutely true. We had really big fires, really catastrophic wildfires also in the past. However, in the recent years, in the Mediterranean, for example, where I live, we have been seeing increasingly more large wildfires, increasingly more intense wildfires. And another interesting aspect is that we are also seeing wildfires that do not go to sleep at night, because these, what we call the nighttime breaks on wildfires that firefighters know and expected wildfires to cease at night due to the recovery of fuel moisture, this window is narrowing dangerously now. And we are seeing even at night intense wildfires that can also exhibit extreme fire behavior. And all these are indicators that something has changed. And there have also been climate attribution studies, as we call them, that have linked, for example, the probability of, let's say, last year's Canadian wildfires that were unprecedented in terms of their size and intensity. They can link the probability of their occurrence to the climate change. And these studies have shown that without climate change, it would be improbable to have such intensive and large catastrophic wildfires.
So these fires that stay up at night, they're just drinking coffee too late in the afternoon?
We wish it was not the case. However, that's not the case, because when we talk also about climate change, it's not only that we are in a warmer climate. We are in a generally warmer climate. However, this warming is asymmetric between day and night. And research has shown that nighttime temperatures are increasing at a faster pace compared to daytime temperatures. And this creates a problem, because during the night, temperatures would normally drop, humidity would increase, and this would allow the fuel moisture content, the moisture that vegetation has, to recover. And when the moisture of the vegetation increases, it seizes down the progression of the fire. However, and we have been, I would say, anecdotally been informed by firefighters that they are seeing what they would call weird behavior, unexpectedly intense behavior during the night. And this is linked, and it has been actually shown in several recent works published in the literature, that indeed, if we go back to the beginning of the satellite era, let's say the beginning of 2000, we will see that nighttime intensity of fire is increasing. And this increase is tightly linked with the increase in nighttime temperatures, the decrease of nighttime humidity, and then we again go down to the loop of what the role of the atmosphere, because this changed, modified nighttime atmospheric environment also creates conditions that are very favorable for the wildfire to draw down upper level higher winds to the surface. And this may create dangerous surprises for those that operate on the field.
And most wildfire control efforts are really focused around the control of the impact of wildfire on human areas or on the built environment, right? But the vast majority of the planet is not highly occupied by people, right?
Yeah.
And probably therefore not, of as much interest for
Mhm.
wildfire control and suppression, which we may or may not be able to ever get a handle on, right? When we have hundreds of millions of acres burning all around the world in
Mhm.
unpopulated areas, like people might think like, hey, we're having a hard enough time just keeping our city from burning, let alone, this mountainous region nowhere.
Yeah, yeah,
So,
that's
so,
correct.
so we're going to have a huge impact, right, on the overall climate from all these fires that we don't know how to control. And as the climate becomes more hospitable to fire, it becomes less hospitable to people. But what does the future of the climate look like, assuming that the changes in the climate data continue or progress or get worse?
Mhm.
Worse, I say judgmentally. But what does that look like for the future for the planet, separately from what it looks like for human beings?
Well, what we can say for sure for the planet itself, as let's say the system of the Earth and its atmosphere, it's virtually certain that the planet there will be some point that it will again reach its equilibrium. It will stabilize. However, as I often like to say when I talk about mostly to students about climate change and the role of humans, what I say is that the Earth will stabilize. The question is where human beings will be when this will happen. And what you previously described is very interesting because another aspect of wildfires that we not really understand and communicate effectively to the public is that there is a vicious feedback loop. Because yes, we focus on coping and maintaining wildfires near our where we live, but the more vegetation we burn, the more carbon we emit in the atmosphere, the more we intensify global warming, and the more hospitable we make the atmosphere and the earth to fire. So this creates a feedback loop that it's currently very hard to break. And we have seen this. I mean, we have seen large wildfires in the Amazon rainforest. We are seeing in recent years large wildfires that may not burn very intensively and be, let's say, good looking for the media in the Siberia, which is a large carbon stock. And all these wildfires release all this stored carbon in the atmosphere. So, without being pessimistic, I would say that our future does not really look bright. And another thing is that we are already underestimating the future extent of wildfires. And this is because all our knowledge, to go back to the beginning of our discussion, has been based on surface weather. So basically, to say it very simply, to have an estimate of how, let's say, future fire danger will look like, we use indices that use surface temperature, surface humidity, surface wind, surface weather variables. And none of the indices we have has been assessed about how the future atmosphere in the vertical would look like and how this change in the atmospheric structure, the 3D atmospheric structure, could impact the wildfires of tomorrow. So we need to really focus on this.
Yeah, and there's obviously a bias on studying what we can see and what we experience in our own bodies as we go outside,
Mhm.
and everything else is theoretical, right? What's
Yeah,
what's the weather like? 10 meters up,
yeah.
100 kilometers up,
Yeah,
right?
this is the magical feature of the atmosphere. I mean, we are born in the atmosphere. Our whole existence is tied to the atmosphere. We would not live on this planet without the atmosphere, and most of our time we forget about its presence. It's only when something changes, like a heat wave, a flood, a wildfire, that we understand that okay, we live in the atmosphere.
Yeah, we don't say, right. I believe there's some writing about that when the two fish are talking to each other. I know the water's kind of cold today. What's water?
Yeah, exactly, exactly.
Right? take for granted the environment that we're in.
Mhm.
So what do you think, if things progress the way they are, what would be the practical changes that the next generations would experience? Maybe you and I have gone out in the forest, or we went camping or something,
Mhm.
because there were woods there.
Mhm.
Is there a possibility that maybe our grandchildren, there won't be woods for them to play in, or it would be too hot to go outside, or the ultraviolet indexes would be,
Mhm.
not palatable for humans to be in? Like, do we risk a real change of what the experience of living on Earth looks like?
I think we are already at this point. I mean, I think it was in the latest report of IPCC that a very powerful figure was shared, especially about heat, and it was a timeline of the anomalies of temperature on our planet, how warm we perceive uh, our living, and it was communicating that it is virtually certain that our children today will live in a much warmer climate than we did. And us, we were raised in a warmer climate than our parents and grandparents were born and raised. So the real challenge here, not only for heat but also for wildfires and other severe weather phenomena, is what we are going to do about that. And it's not that it's something that we cannot avoid. We are not saying that it's something unavoidable. However, we need to adapt. This is number one priority, to adapt to the new environment that we created on our planet, and focus also on mitigation. However, mitigation also includes policy, intergovernmental collaborations. It's more broader, and it involves cutting down carbon emissions. So, but number one priority is adaptation, and the tools we have for adaptation, for example, include the early warning systems, information systems, all the knowledge that we can produce and we can offer for the protection of the society.
Well, you talked about, optimism versus not looking too bright ahead. And you talk about the role of government
Mhm.
and international cooperation. Are there solutions that can be more at the individual level and at the municipal government level? Because I'm not sure what it's like in Greece, but if you're waiting on the federal government in most countries to solve any problem, it's never going to happen, let
Yes.
alone if that government then has to cooperate with another government.
Mhm.
You could be decades in the future before you saw any results.
Yeah.
So perhaps, we more practically just need to look at things that individuals can do and local communities can do, that they could do right now.
That's totally true, and I agree. I mean, yeah, we can talk about the intergovernmental collaborations and the effort put by IPCC to cut down emissions and the difficulties in getting all the governments agreed to cut down emissions. But in the very end, the one thing that we don't, I believe that most of us, including myself, don't realize is that cutting down carbon emission is not only something that the government will decide, because cutting down carbon emissions means consuming less energy. And so the real question is, on an individual level, am I ready to reduce the energy I consume on an everyday basis? Either we talk about taking my car, or the electricity I consume, or the gadgets I have plugged in, everything. So, in the very end, on an individual basis, what we can do is try to reduce the energy we consume. This will reduce our carbon, what is called our carbon footprint. It's not only a matter of getting the governments together. Of course, it's very important, and yeah, we need to have them all together and agree to take real action. But in the very end, if, for example, the Greek government would say, okay, I'm going to cut down carbon emissions totally, this would mean that we would need to reduce our energy demand, because most probably we may not cover it from renewable energy resources, at least not all the time. And so, yeah, it all comes down to us.
Yeah, so obviously one of the things we could do, if we want to reduce our energy consumption is to reduce our energy expenditure. So I think I will start by sleeping more.
Yeah, that's a good point also for our also for our health. Mhm.
Yeah.
Yeah,
How much sleep do you get? I'm curious.
I get around 6 to 7 hours. I try
Six.
to wake up really early in the morning, both because I'm more productive in the morning, but also to avoid the hell of the traffic in
I
Athens.
see. So you commute?
Yeah, I commute because I live about 20 kilometers from my workplace.
I see. And do you think that as we see more remote workers, we'll have less commuting and less, petrochemical release?
I think that's the experience we had during the COVID era. I mean, yeah, remote working was the norm in this era, but I think especially in the private sector, I more often come across people that do remote working. However, I'm not sure it's really good for our mental health. I mean, at least for myself, it didn't work out working from home. It may work out sometimes and feel okay, but most of the times it's not the occasion.
I see. When we talk about your work, we're kind of talking about the aggregate of what you've been working on over the years. What
Mhm.
does your day-to-day life look like? What type of problems do you work on a daily basis?
Yeah, on a daily basis. Uh, I will talk about this period and now that we're entering the fire season in Greece, because the fire season begins on the 1st of May and so until the end of October, we're officially in what we call the wildfire season in Greece. My day begins by reviewing what fire weather conditions we have now, reviewing what we expect in the next few days, and if we see that we anticipate dangerous conditions upcoming in the next like 3 to 5 days, start, let's say, hitting the alarm for the public and the authorities about the upcoming conditions. Other than this, the research we do, and I personally do, includes also a lot of administrative work and monitoring in the frame of a European network we have about advancing our understanding on extreme wildfires. So a lot of programming. I work a lot of with Python programming, a lot of analysis of conditions in the past. So looking back to understand how fire weather conditions have changed. So and how these changes may correlate or relate with changes in the fire behavior or in the fire occurrence, trying to understand how things work. And more broadly, I would say that I and my team try to tie down our work down to practical issues, doing research that really matters, because my motto is that we don't do science for science. I mean, it's interesting, and if anyone else wants to do science for science, it's pretty cool. However, I like to do science that one way or another matters for someone out there, and we try to develop new, let's say, products, new services, new tools, kind of intelligence that could at least help someone make a decision. Because we already know that what we do, what science do, will never be able to make a decision on itself. It helps people make decisions.
So when I think about science for science sake, I think about like astrophysics and studying other galaxies.
Mhm.
There's, it's interesting. It makes really cool photographs, but
Mhm.
it's probably not going to have any big impact on our quality of life here in the near future.
Yeah, that's true. But this does not diminishes the importance of astrophysics and cosmology in trying to understand. I mean, I think it's a matter of what do you want to do as a person. I mean, if I go back to my graduate students, I always wanted to try to explain what was happening in nature, and I was more triggered by a desire to produce something that someone could use.
Yes.
just to help him in one way or another.
So when you're working with your graduate students, what are some of the personal attributes and habits that you would like to instill in them to make them more successful adults and scientists?
The number one, I think, value I would like to transfer to anyone is integrity. This is the number one value of myself, and the next one is passion, because you have to have passion for what you do, and you have to have integrity in what you do. And this is very important, especially for research, because we talk also about chasing research funding. This is something that we fortunately or unfortunately have to do. In order to fund our research, we need to go out and, let's say, chase research proposals. And in doing so, you have to retain your integrity, not be drawn to doing and delivering something you don't believe to, not be drawn to deliver something less than you promised, and all this by being also passionate and wanting to real help.
And so those are traits that we would like them to have.
Mhm.
What can you do specifically to inculcate those traits? How do you develop passion within a scientist, or within a young scientist?
You
What
lead
do
by
you do to help them, become more passionate about their work?
you
Is it
lead.
innate curiosity, or are there experiences that you can give them that increase that?
Yeah, I think it's experiences, and I believe that the most valuable experience, at least from my own experience, is seeing the example. And I'm not talking myself, but you have to somehow lead by example. Show them what means to have integrity. Show them what means to have passion for what you do. This is how people learn. We learn by example, and we also learn by listening to stories and looking at stories. So this is the path. Of course, you can teach integrity in theory. You can teach integrity, passion in theory. You have to give them real examples, real people with passion, real people with integrity, and or I would also say another thing that I would also say is expose them to diverse sources of experiences, and one of them could be reading autobiographies of people that were very significant and lived on Earth.
And who would be some of those people that you would recommend they read the biographies for?
Now, I would say definitely Albert Einstein, Steve Jobs, Marcus Aurelius, and Aristotle.
That's a pretty good collection.
Like,
That's great. And when in your work, who are your peers and coworkers that inspire you?
I think that especially when we talk about fire meteorology, I was very lucky to be inspired and now consider him a peer and a connection and a friend by Greg Clements. Greg is currently a professor at the San Jose State University in California. He's also the director of the Wildfire Interdisciplinary Research Center. He is what I consider right now the top expert globally on fire weather and fire atmosphere interactions. So when I started getting myself into fire meteorology, because when I did my PhD, I was mostly numerical weather prediction, so I gradually shifted to wildfires. I would say that, yeah, I was reading his paper. I considered him to be a role model, and I was very lucky to also meet him. We now have a collaboration, so I would say that, yeah, he's a role model, at least from the scientific part of it. Mhm.
So useful, isn't it?
It is having someone even if he's not or she's not right next to you, so you have let's say everyday interaction. but having someone to consider as a role model or a mentor is of paramount importance. And I think going a bit back to our discussion, this is also important when trying to instill values to graduate students. Having mentorship programs is really important. Mm-hmm.
Absolutely. And you have a major wildfire conference coming up in Greece, don't you?
Yeah, we
One of the islands, right?
we have it in Cyprus. Actually, it's not in Greece.
Okay.
But
Nearby.
we are sister countries. Let's say, we have it in Cyprus. It's this September, in the last week of September. We call it X-Fire. It's the first international workshop on extreme wildfire events. We aim to establish a dedicated forum for these extreme wildfire events because we believe that they are totally different from the wildfires we normally got in the past, and we still get, let's say, normal wildfires. So being that different and having these fire atmosphere interactions and this coupling with the atmosphere, they deserve a different approach to be studied. And we envision that this could serve as a forum for exchanging knowledge, but not only from the point of view of science, because we already said that doing science for science, at least for us, is of low importance, but we will also try to bridge practice with science. So we aim in this workshop to have also practitioners, firefighters, fire managers, civil protection professionals, so that we exchange information, so that we assimilate what one knows from another in order to be able to co-produce knowledge and produce knowledge and intelligence that could be really applied in the field. Because, Steve, one of the things that science does quite often is that it produces more than let's call them, the end user can consume. And
yes.
so does wildfire science. We are now producing much more than the firefighter, than the fire manager can consume. So the real question is how to start producing something that is context aware and can be really, really helpful, instead of simply being fancy or AI driven or having all these, let's say, advertisement like features.
Yeah, I wondered because I looked at X-Fire and, and as soon as they write something like, call for papers or call for proposals or something, my first thing is, oh, it's another bunch of academics getting around to talk about the sophisticated science side of it. Is this a place where, practical advice could come, where practical people would be welcome,
Yeah, exactly.
who are actually working on something that could be applied right now that's going to reduce fire risk or, wildfire suffering.
You are very correct to call this out, and this also gives us food on how we will advertise next versions of X-Fire, because it's I'll tell you why, because it's not that way. I mean, we will have both academics doing and presenting their science, but and this was not communicated. This is why I say how we will advertise next year's X-Fire. But we will also have a dedicated session where we will have fire managers, firefighters, civil protection professionals invited without going with the abstract submission and all that academic stuff. And we will also have a half day. We have named it Stakeholder Roundtable, where we will have people from the field sharing their insights and scientists, researchers listening. Because the first step is learning to listen and build the trust. Because I feel right now, and I have been leading the NERO network, this European network on extreme wildfire events, for almost 2 years now. And my experience is that we do not have trust among the two communities, the researchers and the practitioners. The researchers, we believe that we can solve everything and we are curious about everything, and we can tell the firefighter what he or she has to do. And the practitioners simply don't have time. They cannot deal with all the cognitive load required to understand all these complex things. Can you imagine me trying to explain to a practitioner about all this coupling of the fire atmosphere and why it's important? I mean,
and vice versa, right? Can you try to imagine the practitioner trying to explain to the scientist, how the fire nozzle works and the pump and the technology that they use or what they have available to them?
yeah,
And it doesn't really matter, right, what the scientific objective is, reduce the heat, reduce the oxygen. Okay, with what?
mhm,
How do I do that?
exactly.
Yeah.
This goes also back to what we previously said. The aim is to try to pack all this knowledge and scientific knowledge, which is very useful, and we need to continue pushing the boundaries of science. But in the end, you have to pack it to something that the practitioner could easily understand, without having to explain to him all the difficulties, all the black boxes, everything. You have to hide the complexity, not hide the uncertainty, because you have to communicate the uncertainty and let him know that what I give you has these limitations, but you have to hide the complexity.
That's right. And yes, what they need to know is not even so much, the physics or of how it works, but how to use it. Right.
Exactly.
I don't know all the physics of what happens underneath the hood of my car,
Mhm.
and I don't need to in order to drive. That doesn't make me, I'm not saying it makes me a good driver either, but right. But I understand how to use the technology,
Mhm.
even if I don't understand
Mhm.
everything under the hood.
Exactly. I think that the problem we are discussing right now begins from the fact that for a long time, and I have also done this myself as a researcher, for a long time we have been working on a model that says that I am the producer, I produce the knowledge, the tool, and you are the user. And I produce something, I give it to you, and you provide feedback, I refine the product, and this loop goes. But in my view, and despite my little experience, this does not work anymore. I mean, you have to reverse engineer from the decision and from what is happening on the field, and reverse engineer to the struggle, for example, a firefighter may have to, for example, on an unexpected wind shift or an unexpected fire behavior, and try to reverse engineer back to what you can give him to aid him next time to better anticipate this behavior, not to make a decision based on AI or whatever other technology, but help him make a decision at that point. And I think that we have not yet gone this way, reverse engineering from the decision back. This is, at least in my personal view, this is the only way to provide context in the knowledge we give to the people.
Fascinating. What a practical approach to science. You talk about the knowledge, the tool, and the practitioner, and there's that middle piece. There's not necessarily a correlation between the knowledge and the tool. The knowledge is knowing what has to happen. The tool is something that's more likely to come from industry or from innovation. That's taking the knowledge and then turning it into a tool that the practitioner can use. But I think there's a lot of scientists who know what the tool should do, but don't know how to build the tool.
Yeah, yeah. You have. We have a scientist to start. I mean, we talked about the fire atmosphere interactions, and these are very complex phenomena and non-linear. Yeah, they're very complex, but somehow, even if we get the measurements, and even if we develop the models, and even we have the perfect understanding, in the end, we have somehow to pack all this knowledge into something simple. Simple, not in the sense of simplified. We are not going to simplify science, but something that I mean, for example, you don't know how a MacBook or an iPhone works, but you can use it. That's
Right.
that's why I also wrote an article on LinkedIn about Steve Jobs, what Steve Jobs would do about wildfires. That is my basic notion. You don't know how it works, how it's what's inside, but you know what to do with it. So, likewise, we need to wrap all the scientific knowledge, no matter how complex it is, into something that one person under extreme pressure with cognitive limits could use. If he is or she is to open a dashboard and then open another dashboard and then go to a web CIS and then go click to a point and get the information, yeah, you've lost them.
Right.
You've lost them. And to do so, again, we go back. It's not that I will do it on my lab or in my office and I will then come to you and say, okay, Steve, I have this. We have to sit together and,
Yes.
and learn from each other.
Yes. Fascinating. Well, so ultimately it comes down to collaboration.
Exactly.
Right?
Exactly.
Someone is gathering knowledge, someone's interpreting knowledge, someone's building on knowledge, someone is using that knowledge to create new tools, and then someone is putting those tools to work. And hopefully that's the feedback cycle that ends up making a difference. Well, Professor, absolutely fascinating. What were we going to say?
It all comes down to collaboration, to being open. I would say that I'm very romantic about openness in science. I wouldn't say that scientists are the most open persons when it comes to sharing data or sharing methods. However, everything comes down to being open to collaborate, to being honest, and building trust. And
Great note, Professor Giannaros. Thank you so much for joining me on the Fire Break today. Absolutely fascinating.
It was a pleasure.
We're talking with Theodore Giannaros live from Greece in Athens. I'm Steve Wolf. You've been listening to the Fire Break. Thanks so much. And the two takeaways from today were integrity and passion. So go do it. Talk to you soon. Take care.